ولما الله مخالفة not Laggoun. Okay, thank you. Okay, go ahead.
Which concern director control using 47 Louanasse Laggoun mount speed regulator of double starter magnetic transmission. In recent years, variable speed drive made of an alternate current machine associated with a static converter have attracted much attention from research groups and the industry. The constraint on the power component limit the switching frequency result performance limitation. The solution is use of high switching frequency component, or we must segment the power. To do this, one of the solutions is to use a machine with a large number of phases. Machine with a large number of phases, multi-fast or multi-star, have been growing interest in the field of electrical machine for several years. The most common machine used is the double star synchronous machine. In recent years, several control techniques have been developed to improve the performance of this electrical machine. Direct torque control is a solution for vector control problem. To solve the problem of direct torque control, we use first sliding mode control. Nevertheless, the first order classical sliding mode has a significant disadvantage, namely the phenomenon of shattering. The disadvantage of this control mode have been minimized by the introduction of high order sliding mode control. The advantage of this strategy of control keep the main advantage of standard sliding mode, minimizes the phenomena of shattering. The objective of our study is the study of the dynamic and static behavior of the double star permanent magnet synchronous machine controlled by direct torque control during a speed adjustment by different regulator, PE and second order sliding mode control and fuzzy sliding mode FD. General mathematical model of the D-star permanent magnet synchronous machine. Part model of the D-star permanent magnet synchronous machine. Electrical equation and magnetic equation, electrical torque expression. To gather system power, D-star permanent synchronous machine. In this diagram, we have network source and two inverter with the PWM strategy of control and D-star permanent magnet synchronous machine. Direct torque control, DTC structure, control of the starter free vector. For medium and high speed, the starter free will depend only on the output voltage vector of the inverter when LS or resistor statoric is negligible. Figure 2, evolution of the end starter free vector for LS or resistor statoric is negligible. The choice voltage vector selection, the desired variation for the flux module, the desired evolution for its rotational speed, the desired evolution for the torque. voltage vector selection, choice of voltage vector. Based on this generalized table of voltage vector, based on this general table, switchboard can be established to control the starter fluid and the electromagnetic torque. Comparison of these two switching tables allow the final synthesis of a single control table through table of director control command structure. General structure of director control of geostar permanent magnet synchronous machine. In this diagram, we have a regulator PE and two blocks of hysteresis comparator, one for flux and other for reverse speed. Switch table for director control and two inverter and block of flux and the torque estimation. Second order sliding mode control. The second order sliding mode control sometimes called sliding mode without shattering, offer very good robustness property for the control of electrical machine. Keep the derivation at zero in a finite time. Second order sliding mode algorithm. The second order sliding mode control have three algorithms: switching algorithm, twisting algorithm, optimal algorithm, and super twisting algorithm. The proposed control strategy is based on super twisting algorithm. The super twisting algorithm now is composed of two parts: a continuous part and a discontinuous part, such that lambda and alpha are positive gain used to adjust the super twisting command. Application of director control, second order sliding mode control. The second order sliding speed controller contains two parts: the equivalent command and the super twisting. The reference torque generated by the controller by second order sliding mode is given by to answer conversion to zero infinite type, the gain can be chosen as follows. Fuzzy logic. Fuzzy logic is an artificial intelligence technique. It provides a very adequate mathematical model for solving problems where one uses natural language expression. Its fundamental characteristic is the use of linguistic variable instead of numerical variable, and to represent uncertain leverage and imprecise. Provide an approximate way but effective to describe the behavior of systems that are too complex or poorly defined, based on fuzzy set theory. General structure of fuzzy controller. The fuzzy controller have four parts: knowledge base, inference system, fuzzification, and defuzzification. Basic starter and design of fuzzy speed controller. The basic shape of fuzzy controller is similar to that of conventional controller. For simple signal variable system, the input of the fuzzy controller are usually the input surface and its variation. Table rule, basic starter, rule table, inference matrix for speed fuzzy regulator. Membership function of the fuzzy regulator, error and variation error, command variation, have 7 membership functions. Application of hybrid control for the second order sliding mode control for geostar permanent magnet synchronous machine. To improve the performance of the second order sliding mode control of geostar permanent magnet machine and to reduce more and more the characteristic and to reduce the shattering effect caused by the thin friction. We propose the use of fuzzy second order sliding mode control, hybrid speed controller, where the sync control function has been replaced by a fuzzy inference system. Block diagram of the proposed fuzzy second order sliding mode control. We replace the PE controller by controller fuzzy second order sliding mode control. Comparative studies between PE and second order sliding mode control and fuzzy second order sliding mode control. It is necessary to compare the static and dynamic characteristics of the 3-speed controller in the same working condition. Figure 9 shows the simulation results, speed, torque, and current during a variation of the low torque set point. Note that the torque perfectly follows the set point. The speed reaches its reference after a small deformation for the case of PE and with a negligible influence which is quickly recovered with its reference for the second order sliding mode control. The use of fuzzy second order sliding mode control command has high dynamic performance compared to other controllers. Figure 10 shows the simulation result. It can be noticed that the use of the fuzzy second order sliding mode control allows the speed to follow suitable its reference value. In fact, this behavior represents an improvement in the dynamic response with a fuzzy second order sliding mode control DTC ALOT or PE second order sliding mode controller. Criteria comparison of the performance index. The results described in the table 6 confirm the improvement performance with the fuzzy second order sliding mode control when we use the criteria of comparison with integral of absolute error, integral square error, and integral time multiplied by absolute error. General conclusion. In this paper, a comparative study between the conventional PE second order sliding mode control and fuzzy second order sliding mode control has been carried out for speed controller of geostar permanent magnet synchronous machine. Simulation results reveal an improvement in the control performance of the torque, including rate, steady state error reduction, and satisfactory performance with the use of the fuzzy second order sliding mode controller. Furthermore, the effectiveness of the proposed algorithm is evaluated and justified from performance indices, integral absolute error, integral square error, and integral time square error. So this algorithm is suitable for application requiring a high tracking accuracy when external disturbance occur. Thank you for your attention.
Okay, thank you.